Welcome. We'll be looking at this example of integration by parts applied twice. This is our sixth example. So here, when we apply the integration by parts twice, what we'll find is that there's going to be a looping of the results, and so we'll have to use like a substitution or a simultaneous equation method along with the integration by parts. I'll illustrate that shortly. So we're going to have, it doesn't matter which one you choose as your u and which one you choose as your v in this case. So if we have u is equal to e to the x, then u dash equal to e to the x. If v dash is equal to sine x, then v is equal to minus cos x. And again, applying the result, we're going to have I1 is equal to uv, which is minus e to the x cos x, then minus the integral of minus e to the x cos x. We can tidy that up a little bit, so we get minus e to the x cos x, and then plus the integral of e to the x cos x dx. So here we see that this part needs to be integrated, and we're going to evaluate that using the integration by parts method. So splitting the page. So I2 now is going to be equal to the integral of e to the x cos x dx. We're going to let u equal e to the x and v dash equal cos x. When we integrate cos x, we're going to get sine x. So v is equal to sine x. Then when we differentiate e to the x, we still get back e to the x. Now again, applying the formula, we're going to have I2 is equal to the integral is equal to uv, so that is going to be e to the x sine x minus the integral of e to the x sine x. So what we're going to now do is we're going to combine, we're going to recognize that I2, which is the integral of e to the x cos x dx to the x equal e to the x sine x minus the integral of e to the x sine x dx. So all of this will migrate to here. So now what we're going to have is we're going to have this is equal to minus e to the x, and let's start off by writing the integral of e to the x sine x is equal to dx is equal to minus e to the x cos x, and then plus e to the x sine x minus the integral of e to the x sine x dx. If we bring together the integrals, we're going to have two lots of the integral. So two lots of the integral e to the x sine x dx is equal to minus e to the x cos x plus e to the x sine x. So the integral of e to the x sine x dx is equal to half minus e to the x cos x plus e to the x sine x, and then plus c. All right, let's have a eagle eye view of everything. And then that will be the final answer. So here, this is of course one of the most challenging types of applications of integration by parts form.